my name is Sarah Withee. I like to call myself a polyglot software engineer. I'm based out of Pittsburgh, and I built an open source artificial pancreas. And here it is. All right, thank you. If you're like most of my friends, you probably have about 50 questions in your mind right now. So I hope to cover at least most of those in the next 10 minutes. So to talk about that, we really need to talk about carbohydrates. So the rundown of how carbohydrates work is that when you eat carbohydrates, your body breaks them down into glucose and fructose. We don't care about fructose for the moment. That glucose goes into your bloodstream, and then your pancreas sees that rise in glucose and starts to make a hormone called insulin. You've probably heard of this. And insulin triggers your cells to start grabbing that glucose and using it for energy. So it's a really important process in your body because your cells need energy to work. Diabetes is when that process doesn't work. I think we sort of have a stigma of what diabetes is, and really it's just some part of that process doesn't really work right. You've probably heard of the two types. The first type is where you have an autoimmune disease that attacks its own insulin-making cells. Type 2 is where you're making it, but your cells really aren't receptive to using it up. So these are the major two types. There's some other types. I'm not either of those. It's a weird story. I'll talk about that later. Find me in the hallway if you want. But I basically treat it as if I was type 1. In the US, we measure your glucose in your bloodstream by something called milligrams per deciliter. It's like 1/10 of a liter. Normal people, or as I like to call them, civilians, usually are between 70 and 99. And diabetics usually aim for about like 70 or 80 to 150, just because it's a lot harder to manage. And of course, when you eat, that number goes up. So even normal civilians that number will go up a bit. We have to manage this. So the idea is we have to do what we can to keep that number in the right range. If it goes too high, what you'll end up is the glucose molecules will start clogging your capillaries, the really tiny blood vessels you have. So you'll end up with circulation problems, which is why people usually have like bad circulation in their feet. They lose their eyesight, their kidneys start to not work right. So that's not really good. If it goes too low, you end up in this state where your body's just like, oh my God, I have to find energy somewhere. So you start shaking, you start sweating. I get a little foggy brain. Some people get really weak. I'm usually out for about 20 minutes if I go hypo. And the worst case scenario, you can even land in the hospital with a coma. So that's not really good. So this is really important to manage. But we find it's really hard because, well, for one, you have to end up calculating your own carb ratio if you're a diabetic. So you have to take a unit, which is 1/100th of a milliliter, basically. So you eat a certain number of carbs, you have to take a certain amount of insulin to sort of counteract it. Usually this is about 30 to 50 grams. It can depend. Mine's on the lower end. I know some people on the higher end. This varies by person to person, though. So the person next to you has a different carb rate than you do. It can vary on time of day. It can vary on different conditions you're going with at any given moment. It can also change over your lifespan, too. So it's not really easy to kind of keep up with. It also gets difficult because your carbohydrates absorb within about 10 to 20 minutes. But if you take insulin, it starts absorbing slowly, but then picks up like 40 to 60 minutes into it. But really takes a full 5 hours to absorb. So really in this end, we have to like take insulin for the food we think we're gonna eat. So that gets really hard to kind of manage to try and keep that level as steady as possible. And then we have a whole bunch of other things, like if you're stressed, it goes up. If you're sick, it goes down. If you drink a little, it goes up because carbs are usually in your alcohol. But if you have a lot of alcohol, it can go down because your blood composition changes. And if it's your special time of the month, who knows what's gonna happen. It's really hard to manage. And this is why a lot of people struggle so much with it. Screaming emoji. So we can use technology to kind of help work with this. And the standard two tools we have to work with this are a continuous glucose monitor. So every 5 minutes, it sends a little reading. I have one on my arm. So every 5 minutes, it connects to my phone over Bluetooth and then tells me my blood sugar reading. So right now I see it's 114, which is not amazing, but not super terrible. And then we also have an insulin pump. So it's connected to a tube that's usually straight into our body, and it checks insulin kind of straight into us. And it's usually a little small pager. You've probably seen some people that have it. But they have to enter in the amount of insulin that they need. So it's like, I know I need to take 10 units, let's say. I have to go in and manually punch that in. So they're great tools, but they're not really automatic per se. So we can use something like an artificial pancreas to try and solve that problem. So there's a couple different types. I'm going to talk about just this one due to time constraints, but it's called OpenAPS. So it's the Open Artificial Pancreas System. So it's a Linux IoT device. I'm running Debian on my pancreas. It also has a 900 megahertz transmitter on it. So that's what talks to the pump. The pump doesn't work over Bluetooth or anything. So you need that sort of bridge device. And every part of this is open source, which is kind of absolutely amazing. So the basic loop process is you get the value from this. It goes to the app I just showed you, which is extra for Android. There's one for iOS as well. It gets stored in Nightscout, which is sort of a database to store these things, but also can be a web UI too. It has a MongoDB backend. And then your pancreas loads in those values, tries to see what's going on with your body at any given time. So about, I think, over 15 minutes, a couple hours, and then like 24 hours. It tries to do some analytics, find out what's going on, and then tell your insulin pump to make some adjustments to that. Who's ready for a live demo? Ta-da! So this is live. As of, I guess, 8 minutes ago, according to this. So my blood sugar is 114 right now. And there's a whole bunch of stuff up here. I won't cover it all. But I can see over here, kind of in the top right, it says -1. So in the last reading, it went down a point. You can see I have about 2.3 units of insulin floating on board. So IOB is insulin on board. Over here on the left, I can see the status of my insulin pump and of my artificial pancreas. So it has 54%, so doing pretty good for halfway through the day. I do have to charge my pancreas, unfortunately. Has about 120 units left in it. The battery's still pretty good, things like that. So good to know those things. The part I want to point out is these are all my blood sugars over the last 24 hours. So you can kind of see it's like mostly green, but there's kind of a couple parts where in the middle of the night it went red. And then sort of got a little bad this morning after that chocolate donut I had. But the blue line is the insulin adjustments. So it's kind of hard to see perhaps in the back, but there's a dotted line that's my sort of default pump level that it gives me all day long. And the blue adjustments are it trying to do whatever it can to keep that as much in the green as possible. Live demos are hard, but also I've SH'd into my pancreas, as one does. I like to think of myself as a cyborg. So this is my buddy Cyborg. A few laughs, okay. I can like check out the log of what it's doing at any given moment. So since you only get a value every 5 minutes, there's usually a little bit of a delay. But kind of up here, you can see it pulled down like a lot of the different values at the top. And then it tried to determine like how many carbs I've ingested recently, and then does some adjustments. But here in the green, it says, you know, it's aiming for like 80, and it's predicting that eventually I'm going to get to about 89, which is above 80. So it's going to bump my rate up just a tiny bit to get it down a little lower. And it's pretty automatic. There's not enough time to watch it, the whole thing. I'll come back in a minute. Yeah. So yeah, just in case it didn't work, I can SSH into it. So a lot of questions I get. For one, I like to offer people to hold it, and they're like, it's not slimy. Like, why is this not in your body? It's not a real pancreas, come on. But it ends up closing this sort of like loop that your body automatically does, so it sort of replicates all the functions. So I kind of call it an artificial pancreas, and a lot of other people do too. Another big question I get asked, is it safe? Like, well, yes. The woman that came up with the original algorithm for all these adjustments, she published all her papers online, so it's a bunch of white papers. She did research on it. You can also see all the code because it's GitHub, but you can also set some hard limits to it. So it will never go above a certain limit, even when trying to correct. So it's always really safe. And I can set those limits myself. So it's, and I've adjusted those over time to try and account for different things. So if this is online, can it be hacked? Like, true, everything can be hacked if it's on the internet. Please don't hack it right now. But it's tethered to my phone, so you would have to like get through my phone and then into the pancreas and figure out what the IP address is 2 layers in, and then break in through Linux, and then find the script to run, and then tell it to like give me all my insulin if you really didn't like me. And then even then, the communication process with the pump is slow, the delivery is slow. I would probably start to notice like things are going haywire long before they actually went haywire. So at worst, you would just be like really annoying me if you decided to hack my thing. So it's really, I don't think it's even worth it. Is it annoying to carry all the stuff around? Yeah, but you'll see here in a minute, I think it's really worth it because it's helping make sure my health is staying a lot better. So yes, I do have to have this. I carry around a bag in my backpack of extra supplies, but I really think it's keeping me in better health in the long run. So I think it's worth it. What if the internet dies, what if the battery dies, et cetera? It goes from a dynamic process back to its sort of manual static process. So I just lose the coolness of having an artificial pancreas, basically. So before Cyborg came into my life, I was usually really high. Most of my numbers were in the red. I'd have a lot of roller coaster days where I couldn't really keep it that much in check just because it's really difficult. Down below, you can kind of see after I got the pancreas in, it's almost constantly in the green. And there's up days and down days, of course. But the blue adjustment, you can see it's really working hard all day long, even when I'm sleeping, to keep that as healthy as possible. I won't go into this. Everything's online on all these GitHubs. I'll post this on Twitter too. But I kind of want to leave you with the thought of what if we took open source and used it to change people's lives and tried to make them healthier? I think we think of large open source projects like Firefox that have massive backing, or like Joe that made some random quirky framework for some quirky bug in some obscure thing once, and like 2 people use it. What if we could gather together and change things to make people a little more better lives? So young people that have it that can't manage it on their own really well, parents could get notifications if they go low. Older people, low-income people, those without health insurance. So yeah, that's my artificial pancreas. Come ask about it. I can show you all the cool things SSH'd into it, or you can just hold it if you want to be able to go home and say, hey, guess what I did over the weekend? Thanks.